in here is, I forgot to write, it says find the equation of the tangent line. Okay, that's what we're looking for. Equation, the whole thing, not just the slope. We're looking for the equation of a tangent line. So let's take a look. We said limit, creating the ratio, and again, if you forgot what that is, this is your first one. So it says f of x, right? That means my function. So it's 4x minus 3x squared. That's my function. Then it says minus what? F of a, right? But do you know your a? What is your a? Your a is what? 2. Well, we say x approaching to a, right? So it's 2, right? X is approaching to a, so it's 2. So technically the next step is, again, I'm looking over here showing you this step. You have to take this 2 and substitute into your what? Function to know the value. Now you already know the value. It's -4, because what is 2 for? It's the point of tangency, right? But this point is on the curve. So that means if you substitute 2 right here, you should get what? -4. So what I'm saying, you can substitute, there's no problem here, but you should kind of work smarter here, okay? Knowing that this is just -4, okay? So I'm going to put minus -4, and again, according to the expression, right here that we have. And what we get here on the bottom, we get what? X minus what? What is your A? 2. So this is what we have. That's our expression. And again, how do we get -4? We took this 2, right? Substituted into the function because the formula said minus half of a. And x is approaching to 2. Okay. Okay, so the next, we have 4x minus 3x squared plus 4x minus 2. We'll put this in order. All right, and then if we substitute, we're going to have 0 over 0, because now I just have to find this limit. So normally when we have rational function, then what? We factor, right? So we're going to factor this. So again, we'll go slowly here with factoring. We're going to factor out negative sign just to make it a little bit easier. So we get 3x squared minus 4x minus 4. And then we'll have this x minus 2. So we will factor the trinomial. And our hope is that one of those on the top will be what? X minus 2, right? So when we factor this, we get 3x plus 2 and x minus 2. So we'll cancel these 2. And we get the limit x approaching to 2, and here we have negative 3x plus 2. And when we substitute now 2 into this limit, we have negative 8. So what we have right now, we just have what? The slope of the tangent line. And now we're using point slope or slope-intercept form. It doesn't make any difference. And find equation of a tangent line. So which one do you want to use, point slope or slope-intercept? We'll use slope-intercept, right? So Minika, what's happening there with you? Why are you leaving, running away?
They have an assembly, but
Could get Dylan Fuchs to the office?
I will take
All right.
I'm sorry, what was that?
I'm doing recording it.
I'm taping this so they will have access to it.
Okay, good. All right. So the slope is -8. So that point slope or slope intercept doesn't make any difference, right? So again, if you, for example, go with slope intercept, so it's y equals mx plus b, right? We know the slope is -8, but also you know x coordinate, right, of that point and also y coordinate. So we have what is y from the beginning? -4, good. This will be -8 as a slope, right? And then here you have, what is x? 2 and plus b. So remember, when we're using slope-intercept form, the goal is to find b, right? If using point slope, this is just will be substitution. So that's what we have. So we have -4 equals -16 plus b, you're right, so b will be what? 12. So equation of the tangent line will be y equals -8x plus 12. So I believe we shouldn't have any problems to write equation of the tangent line as long as we get the slope right, yes? Okay, so this is what we have with this. Any questions here as the process goes?
Hey, class.
All right. Okay. So let's take a look. Okay, so the other thing is, let's see. Like I said, if you look at my notes, you're going to see the same problems where I use the second one. So you will have that. That's not a problem. Now what I'm going to do right now, I'll give you the second problem. And this time, this will be, let's say, y equals, it doesn't make a difference if I write f of x. So it's 2x plus 1 over x plus 2. And the point of tangency will be 1 and 1. So you see, function changed. Now the previous one was quadratic function, right? Yes, no? Okay, so polynomial, let's say. Well, this one is a rational function, so we'll see a little difficulty here just in the process, but the same idea, the same substitution. And then we'll find quickly equation of the tangent line. And then I will talk to you about the derivatives. But these questions, I mean, like number 1 and 2, you will have on your homework assignment where you have to find equation of the tangent line. So, well, this time, excuse me, this time I will use the second definition, okay, just to show you the difference. So, still speaking about slope of a tangent line. So, limit. And remember, when I go with the second definition, we say what? H is approaching to 0, okay? And we'll have over H as the second one. Again, quickly I'll show you the second one, and you remember what I'm talking about. This is the second one, when we have f of a plus h, okay? This is what we have. Now, this problem is very specific because I know what my a is. What is my a? 1, right? That's my a right here. Now, I could, for example, use a over here, but at the end I will substitute 1 for a. But it's a little bit easier to work when you know what a is. It's just easier to work when you know what a is. So it's 1. So in reality, I'm looking at this f of 1 plus h. You understand what I'm saying? Your a is 1 minus f of what? 1. And that's what I'm doing. Looking at this limit. So let's just start substituting. And here you can have a little difficulty if you're still not sure exactly how to substitute into function. But what is f of 1 plus h? It's the composition. So what we're talking about here, taking 1 plus h and substituting instead of every what? x that you see in your function. Okay, you have to remember this. And again, one more time, it's not f times, right? It's not. So, what do we have? It's going to be kind of a little bit messy here because I have to create complex fraction here. But what do I have? I have 2 times 1 plus h plus 1, so that's this, the top right now, over 1 plus h, right, instead of x, plus what?
2.
Plus 2. Then it says minus f of what? 1. Well, you already know what that is. It's 1, but if you want to substitute, why not? Put 1 and you get 3 over 3, right, which is 1. So minus 1. And on the bottom we have h. So what I really have here from calculus at this moment, again, we're taking calculus, just limit h is approaching to 0, but over here it's just difference quotient, and you need to know how to simplify it. This can be complicated, again, if you don't feel comfortable with this. But let's just go through it, see how we go through the process of simplifying this. So I have to open parentheses here, okay, combine like terms, everything that I can do just to make it smaller. So I will have, right here, looking at this one, we have 2 plus 2h plus 1 over h plus what? 3, right? If you look, here's your h, and you open parentheses 1 plus 2, right? H plus 3 minus 1 over h. Still we can simplify, right? 2 plus 1, I should do it, but I kind of overlooked that, so let's just add this quickly. So we have limit, h is approaching to 0, so we have 2h plus what? 3 over h plus 3. Sorry, I can't write this well, over h. That's what we have. Again, one thing here, don't make the biggest mistake sometimes students make when they just cancel 3 and 3. Can we do it? No. You can cancel factors, right? Not by the terms like this. Can you just do it? So, what I have to do now, this is my complex fraction, right? Let's do it step by step. And I think I mentioned this before. You learn this kind of doing it a different way, but overall, most of you probably know we have to take care of the top, right? Make this the normal fraction, and then divide by h. Okay? So, what do we have here? We have 2h plus 3 over h plus 3, and minus, if I want this to be h plus 3, I need to have what? h plus 3 here, right? Remember, it's 1. And over h. So, when we put this together, h plus 3, and what do we get on the top? I can just write the whole thing. 2h plus 3, then what? Minus what? h, and minus 3. Because what are you subtracting? You're subtracting what? Quantity of what? h plus 3. But then you open parentheses because of this negative, right? Right here. Then you change the signs. You have to be very careful here. And it's still over h. So it's getting a little bit better, but yeah, it takes time to go through. So here we have h plus 3. And what do we have on the top?
H.
H plus 3 and h minus 3. So on the top, think about this piece, right? So 2h minus h will be h, right? And 3 minus 3 is 0. So we have just h. And over what? H. Okay, now don't be confused with this h, right? It belongs to the one that we had before. But now I have this kind of 1, 2, 3, three-story kind of fraction. So what do? We take this, right? And we divide by h, but division by h means multiplication by 1 over h. So we'll have this. Again, you can skip this step if you see what the answer is, but I have this. I have h, that's this one. I have h plus 3, and times by h. Can you see how we move from here to right here? So we take this, right, and divide by h, which is multiplication by 1 over h, and that's why it's here. So now we cancel these. So we have limit h is approaching to 0, and we have 1 over h plus 3. So what will be the answer? 1/3. So that's my slope, that's the slope of a tangent line. So as you see, there are lots of algebra here. And it's easy to make a mistake. Okay, so you have to be very careful. You have to look through, see what you have. Now another way, for example, to check, I'm talking about homework assignment, okay, overall right now. Another way to check if you would do this right, remember we still have the right equation, right? You graph the function, you graph your tangent line, right? And then what? See if they will touch each other at what? 1, 1, right? So quickly, let's just finish writing this equation, okay? Let's use point slope. Y minus y sub 1 equals mx minus x sub 1. So we have point slope. Okay, so we know what we have for y sub 1, that's what? 1. So minus 1, slope is 1/3 x minus 1, because point was 1, 1, right? So y minus 1 equals 1/3 x minus 1 over 3. So we're going to add 1, right, to both sides, adding 1. So y equals 1 over 3x, then what? Plus 2/3. And this will be the equation of the tangent line. Okay, so, I mean, I cannot show you every function in the world. That's impossible, right? You have to get the idea, you have to see the process, and then, I mean, it's kind of the same concept, but you have to be kind of careful with the process. So, are you okay with this? Again, I showed you with the first definition, with the second definition, and now what we're going to do, now we're going to talk about what derivative is, okay? Now, we're not going to go too deep today. When we get to chapter 3, then we'll go deeper, so you'll see what the derivative is more, okay? But right now, basically, I'm going to write this. To make it simple, what's derivative? Well, derivative is just the new name, I'll put it easy, okay? New name for the formula number 1 and formula number 2. Okay, so look. If I have, and I'm going to leave some room over here to make sure we can put the notation for the derivative, but overall I'm just going to copy the first formula. Okay, same thing I'll do here. I'm going to copy the second formula. Okay, so what did we call them before? Yeah, slope of tangent line, yes, no. Also, I'm going to add to this because I didn't mention this, but remember in section 2.1 we said what? Tangents and velocity, right? So also I could write the same thing for the instantaneous velocity. Remember instantaneous velocity? The only difference, I'm not going to say, for example, f of x. I probably will say s of t, right, as a position function. You understand what I'm saying? But it can be written the same way. So we're looking at two formulas at this moment. They represent slope of a tangent line or instantaneous velocity, let's say, right? Yes, no. But general word for this, just the derivative. And we write this as whatever function you have, f, I have f function, and we say f prime of a. That's how we show that this is the derivative. Okay? That's what we have. Same here. This is exactly the same. F prime of a. And again, we're starting slowly. We'll get to the big concepts later. Right now, that's what we have. So technically, for example, if I say find the equation of a tangent line, we all know we need to find slope of the tangent line, right? I technically could say we need to find the derivative. And that should quickly click that we're looking for what? Slope of the tangent line. You understand? Well, derivative overall is not just slope of a tangent line. Now we're trying to talk about something that's more familiar to us, okay? Or the velocity. Anytime when you have something like this, when we're talking about rates of change, the derivative overall will just come on the scene. And rates of change basically means what? How fast something is changing, right? Yes, no? So that's why we're talking about velocity, because what's the velocity? It's the speed, right, to some extent. Yes, no? You know what I'm saying? Okay? Same thing we can talk about as, say, business concept. We call it marginal cost. So basically what that means, it means how fast its price is changing, okay? So every time when we have a concept how fast something is changing, that's why we will talk about the derivative. Okay, and I just don't have time right now, but next time I'll put it on the screen. Actually, it's in your book. Actually, it's the last paragraph, but I'm trying to remember if it's 2.7, 2.8. I didn't check that. They have a big paragraph saying, in mathematics, we use a concept of the derivative. But in every discipline, we have a completely different word that describes the same thing. So like for me as a mathematician, I'm going to say derivative. But you being, for example, pharmacist, you will talk about how fast drugs are reacting. Okay, that's your derivative too, as long as you have a function. Okay, so that's what we have here. So we're not going to go too deep, just as a concept, that's what we have. So the next question, for example, will be find the derivative. So again, what's in our mind? Get the slope of a tangent line, just to make it something easier, okay, that you can understand. So let me put another function right now, and we will be looking for the derivative of this function. So, for example, this will be number 3, yes, no? Okay. So for number 3, let's say I have a function f of x, which is 4 over square root of x, and it will say find f prime of a. So, as you see, it doesn't say find the derivative, right? So you need to know what that prime means. F prime of a means find the derivative. Obvious, nobody's asking you to find the equation of a tangent line. Do you understand that? So you find that limit and you stop. So let's do this. So here's my question to you. I'm not going to ask you, okay, I want to ask like which one to use. I actually will use first one because I want to show you something, okay? I'm going to use the first form. We can use the second one, but I'll use the first one. So what I'm writing, I'm not writing m, do you understand that? Because the question is what? Find the derivative. So I have to write f prime of a equals. And after this, like I said, overall you can choose the first or the second. But I'm going to use the first one. So we say limit x is approaching to a. Again, what do we have? F of x. I will be writing this a couple times until you kind of fix this in your memory, that you know them. Because on the exam, on the test, I will not give you formula 1 and formula 2. I'm just going to say find the derivative of the function using the definition of the derivative. The definition of the derivative, this one or this one. So you need to know what to write. If you cannot, that means you're going to get it wrong. But the second piece, because it's a two-step question, kind of. The next question, when you find the derivative, knowing that behind, that's the slope of a tangent line, I'm going to ask you to find the equation of a tangent line. So technically, if you get derivative wrong, then what? Your slope is wrong. And the next problem is wrong. So you have to be very careful. So let's just use our function, plug it in. So f of x, right, that's my function, is 4 over square root of x. Then minus, then says f of a. What do I put here? Well, you know how to find f of a, right? What do you do with a?
Plug it in for x.
So what do you get?
Square root of a.
You get 4 over square root of a, right? That's your f of a. No, I'm not giving you a number on purpose, okay? Because I want you to carry that a over. So, and over what?
X minus a.
X minus a. Well, this is your limit that you have to find. That's what we have. So it's kind of similar to the previous one. I see complex fraction. So I want to simplify this fraction. And I will be dealing with the top piece. So what's LCD just for the top, ignoring these?
Square root of a times square root of x.
Right? Yes, no? Square root of x times square root of a, or square root of a times square root of x. So what do I get? I get 4 over square root of x. And here we'll have what? Square root of a, right? I don't know if I have to do this step by step like this, but just in case. Minus what? 4 over square root of a, you'll be multiplying by square root of what? X and dividing. And over x minus a, right? So if we put this together quickly, we have one common denominator on the top, right? That will be square root of x times by square root of a. And here you have 4 square root of a minus 4 square root of x. So that's my numerator, but now I still have x minus a. So far so good with algebra? Can you see the step? Do you understand? Okay, so now equals. So what do I have to do right now? I have to make it normal, right? Normal fraction. So it's the same thing. This divided by this, so meaning multiplication. So limit on x approaching to a, and what do I have? I have 4 square root of a minus 4 square root of x over square root of x times by square root of a times by x minus a. Okay, that's what I have. Now when you substitute, what do you get? You kind of should know now what we'll have. Because remember, since we have only one point to deal, we'll get what? Speaking about like slope of a tangent line or something, we have what? 0 over 0, right? Because if you put a, what do you get? 4 square root of a minus what? 4 square root of a, which is what? 0. And if you put a for x, right? This will be fine, but we get what? A minus a, and that's 0. So now what you see here is just a limit. So the next question, how are we going to find this limit? What do you have to do? I'm going to tell you the hints, give you the hints, right? What do you have to do with 0 over 0 if you have square roots?
Conjugate?
You have to use conjugate, right? But I'm not going to use conjugate. Because, well, okay, I told you we can use conjugate, right? And probably I will factor out 4 to make it easier. So I will be multiplying and dividing by what? Square root of a plus, right? Square root of x, yes, no. And dividing it by the same thing. Square root of x, no, sorry, square root of a plus square root of what? X, conjugate. You understand what I'm saying? So I just want to make sure you see this. But why I'm not doing this? Because I want you to see the factoring. Because remember, 0 over 0 can be solved by factoring as well, if we can. So, question, can you see what you can factor?
We can factor 4 minus square root of a plus minus square root of x.
Okay, I can do that. Okay, I know you really want to do this, so I'll do it. But that's still not what I really want from you, because that still doesn't solve the problem, right? And again, I'll repeat, you can use conjugate here. That's still good. But I want you to see if you can factor something besides 4. Now, what is your goal? Let's talk about it. When I say factor, that's factoring with purpose, okay? Not because you can or you can't. What do we do normally when we factor? We want to see what? Something on the top and something on the bottom, exactly the same, yes, no? To what? Cancel them, right? So when I say can we factor, I have a purpose. I want to factor something to get something on the top and the bottom the same, and I can cancel it. And this can be difficult, okay, overall to see. But let me tell you what you can factor. You can factor x minus a. No, you may not see this because how do we look at the factoring? Do I have greatest common factor, right? Well, there's nothing here, right? Then, well, you say, well, what do I factor if it's just x minus a, right?
The square root of x plus, that's a difference of two squares, and we use the square root of x and a, right?
Yes, it's a difference of two squares actually right here. If you think about square roots. So you can factor the bottom x minus a. You can factor this. So we have 4. Okay, we have 4, and then we have square root of a minus square root of x, almost at the end. Square root of x times by square root of a, and this one we have will be square root of x minus square root of a times by square root of x what? Plus square root of a. Now, in general terms, I'm going to just say this. Remember, when you did this in pre-calculus, or let's say, maybe algebra 2, let's say, whatever is plus or 2, normally we say there are limitations to factoring, but if you think about calculus, calculus can push more in terms of factoring, and even algebra 2. You just didn't see those kind of challenging problems, okay, with factoring. But why did I do this? Tell me. Now, if you look at these two, obviously they're not the same, right? But if you will factor out negative from this one, you will have negative 4, and this will change to what? Square root of x minus what? Square root of a. See, I'm doing lots of algebra right now. So my hope that you have absolute no problem with algebra concepts. So these will be canceled. Okay, but like I said, you can use conjugate. If you don't see factoring, don't suffer. Okay, try to use the conjugate. So when we continue with this, what's left? Negative 4, right? Over square root of x times by square root of a and square root of x plus square root of a. And that's it for now. Sorry, I can't see it. I'm going to move this up. Well, and now we have to substitute, right? So let's see what we get. So we get negative 4 on the top. What do we get right here when you substitute a? You get what? Square root of a times by what? And that is a, okay? Times, and then you put a here, so you get a square root of a plus, right? Square root of a, what do you get? 2 of those, right? 1 apple plus 1 more, get 2 of those, right? 2 apples. So we get 2 square root of a. Now, definitely I have to deal with negative 4 and 2, right? So I will have negative 2 over a square root of a. Now, overall, again, this is a general statement right now. In calculus, we're not really pushy for rationalization. Remember what it is? To get rid of any root square and the denominator, right? But we can do it. So, for example, I will continue with this, okay? And I multiply this by square root of a and divide. So when I multiply, I get negative 2 square root of a over what? Can you see a squared?
Yeah.
Square root of a and square root of a gives you just a, right? And a times a is what?
A squared.
A squared. And that's just the derivative. So if we look at this overall, the process, it's time-consuming process. That's why we have chapter 3 and chapter 4 to find new ways of finding derivatives, okay? So right now, we're working with simple functions. Again, 4 over square root of x is a very simple function. Okay, the rational function before is also very simple, okay, function. These we call simple functions, and we can deal with the limits. But when a function gets more complicated, we're really suffering there because it's more complicated. It's still doable, I'm not saying not. For example, if I will ask you to find the derivative of the sine of x as a function. So you technically will have what? Sine of x minus what? Sine of a, right, over what? X minus a. Well, try, what are you going to do with this? Okay? Or if you put, for example, a plus h, so then you get what? Sine of a plus h minus sine of A, right? That means you have to go into identities to expand and all that. So it's more complicated. And when we get to the topic of the derivatives of trigonometric functions in chapter 3, just to find the derivative of sine of x, and they meaning the book, they put like 2 pages of work just to find the derivative of sine of x using this concept. And now they're going to say at that time, okay, here's the derivative of sine of x, use it. Don't even look how we did this, okay? There are lots of work, geometry involved, and many things. So derivatives, I mean, later on will get easier to find. But what will be the challenging at that time when we go away from the limit? Because limit is just a definition, right? In terms of how to find, with the formulas that I gave you, okay? But when we get to that time when we start looking for limits, the way to find limits will be much easier. But what will be difficult, the functions will get more complicated because now you don't have to go through limits. All right? Do you understand this? Okay? So, let's see what we have. 307. Okay, we're going to stop right now. Okay, you will have a CAD for 3.8, okay, for Monday. And on Monday we'll talk about the exam. Okay, but I think I already posted, or I will. I don't remember the review assignments. Trying to remember if I did. Okay, so I'll do it today. All right. So keep practicing. Let me know if you need any help.
You know that function for the derivative, both of those. That's key. Nope.